Good morning everyone. In this video, we are going to discuss about Otto-Hoffmann method for byproduct oven. This method is widely used in industrial process for manufacturing metallurgical coke. This method not only produces coke but also recovers valuable byproducts such as coal tar, ammonia, coal gas, etc. It developed the byproduct coke oven process used for manufacture metallurgical coke, which improves thermal efficiency and recovers valuable byproducts, which in turn widely used in iron and steel industries. Okay, so generally why it is preferably uses, that's very important to note that the generally BE ovens have been replaced by chambers oven, which works on regenerative principle of heat economy. Okay, all the valuable products are recovered from the outgoing flue gases. Okay, so traditional BE ovens wasted energy and byproducts in general. So it is very important to replace it because to store some energy and the byproducts, which in turn used for several applications. Industries required high quality coke with better fuel economy. Environmental concerns demanded efficient recover systems. So how it is constructed? So it consists of a narrow silica chambers, and chambers arranged side by side with vertical flows, charging holes provided at the top. Okay, and gas offtake valves and iron doors also included. Hot regenerators will be there. These regenerators, which in turn give equal amount of heat energy to that. So Otto-Hoffmann's byproduct oven is designed to produce this coke, which has been designed on the regenerative principles of fuel economy. Example, heat produced in the process does not go to waste, rather it is reused itself in the process itself. The working of the oven is such that fuel is introduced in the oven in carts where they are provided heat for the combustion process. During the combustion process, several gases are emitted from the oven, which are made to exist from a proper channel. Okay, so that is a important thing in this design oven. Before these gases leave, they transfer their heat to the brick that work, which again provides heat to the process, which in turn it supplies the heat equally. That's very important here. So working principle: coal is charged into silica chambers. So and chambers heated to around 1200 degrees centigrade. It means the chambers withstand the very high heat, means 1000 to 1200 degrees centigrade. Then it gives a equal amount of heat energy, okay, for the working of the oven. Air and produced gas are preheated, and here carbonization occurs in the absence of air. So in the absence of air, we know very well, high temperature of making carbon material, that is called carbonization reaction, that is happening here. Coke formed is removed and quenched with water. Okay, so finally coke formed here is removed with and quenched with water. So regenerative heat economy. So hot flue gases heat will check the brick regenerators. Here incoming air and gas become preheated in this process. We can see those in the picture. Okay, mechanism picture. Direction of gases reversed periodically, so that gases would be reversed periodically. Heat would be supplied in stable way. There won't be any fluctuation here since the heat is supplied from the bricks. That's why the hot regenerators would be there. Improves the fuel efficiency and reduce the heat loss. That is very very important here. It reduces the heat loss. So these are some of the uh, recovery byproducts. Generally, coal tar, ammonia, naphthalene, benzene, coke oven gas. These are some of the main byproducts here it is used. So how it is, it is used in a different way. So the Otto-Hoffmann process converting coal into metallurgical coke while capturing the volatile gases releasing during the process. This system ensures that valuable chemical byproducts are not wasted. That is very very important. In other ovens, byproducts would be wasted, but here it won't get wasted. That is the important thing happened here. Coal tar. For what are all the uses? Coal tar would be used in road construction and in chemicals raw material for producing dyes, paints, etc. And wood preservation, waterproofing, etc. Here applications of coal tar. And then ammonia, fertilizers, chemicals, refrigeration. Fertilizers converted into ammonia sulfate for agriculture, used in the production of nitric acid and soda ash, etc. Coke oven gases, fuel used as a clean gaseous fuel for industry furnaces, which in turn supply to municipal gas pipelines also. For domestic heating, it is very very important, which is a simple thing also to the regular domestic purposes. Okay, historically used for gas lightening. Which one? Coke oven gas. That's very very important here. And then naphthalene, pest control used to manufacture mothballs, base material for synthetic resins, dyes, and especially polyvinyl chloride, popularly called as PVC plastics. And what about benzene here? Solvents used to dissolve fats, resins, and rubber based material. So a building block of plastic C6H5CH double bond CH. It is very very important here. Synthetic fibers and detergent. That is uses of benzene here, and also a toluene and xylene method. So it's solvents which act as a strong thinners for paint, lacquers, and adhesives used to synthesis organic chemicals and explosives. These are some of the chemical feedstock and mainly toluene and xylene. Okay, so thank you for the discussions.